Hi, my name is Lauren Oktovic, and today I will be presenting to you spectroscopy of simple molecules. First, we have to identify what each of these compounds are based on their IR and NMR spectroscopy. To do this, we will use these and find functional groups as well as ratio of areas and peaks to identify what these compounds are, and after we identify them, we will then be able to determine the environmental and health effects of each one of these. So first, we have to use our Chemistry 120 laboratory manual and use the instructions within it to determine how we go about this experimentation. First off, we need to use the 2 paper and 1 liquid sample and use the IR spectroscopy and NMR spectroscopy to determine what parts are within these. After that, we will then collect the data, print it out, and analyze it. Based on this, we will be able to use the IR to narrow down the functional groups, and then the NMR to find the final compounds. Starting with the IR spectroscopy, we can see that we use this group with the absorbances to find each of the functional groups. Each has their own absorbance, and notice that some of them have broad or strong ranges that you have to note when looking at these. Using the NMR spectroscopy, we can find the peaks and the ratio of areas and be able to finally determine the one compound that it actually is. Note that when looking at the IR spectroscopy, I highlighted the CCl and CBr absorptions because for these, we often do not look at them when there's other functional groups present, but if there are no functional groups present, you can look at these to try and determine which compound it actually is. So as you can see here, we have our 16 unknown compounds that were given to us in our laboratory manuals, and each of these have their functional groups for IR here, their peaks and ratios labeled over here. We will then use these to help determine our compounds. First, we started with IR spectroscopy. Looking here, we use this absorption graph again. On sample 59, you can see that right here, we had an OH group with a very broad band. These must have broad bands or they are not counted as a hydroxyl group. Over here, we have a C to H singly bonded carbon group, and those are the only 2 that are found within this one. In 59.1, we found a C to H singly bonded group and a C double bond O group. Note that each of them have their very own absorbance rates. On this one, we have several places where you can see C to H benzene absorbances, but you want to focus on these ones with the higher peaks and the stronger peaks because that will show a better idea of where it will be, as well as we have C to H singly bonded groups over here. This chart just shows the basics of all of the functional groups that I found within each of these, which we will use later to determine what compounds these are. Next, we were looking at the NMR spectrum. So here we can see that there are 3 peaks, and these will have a 6 to 1 to 1 ratio. These ratios and peaks will again allow us to determine what the compounds are. In 59.1, we see a 1 to 1.5 to 1.5 ratio. By seeing this, we know we have to multiply it by 2 to get an even ratio of 1 to 3 to 3 for our 3 peaks. For 59.2, we only have 2 peaks, but it is again 1 to 1.5, so we also have to multiply this one by 2 to get a 1 to 3 ratio. By looking at this is our final chart of having 3 peaks for this one, 3 peaks for this one, and 2 for this, as well as our ratio of areas over here. By looking at this, we can use our IR and NMR spectra to determine what these compounds are. In our first one, we are able to use our IR groups of the hydroxyl group and the C to H singly bonded carbon to determine that it could be one of these 4: methanol, ethanol, T-butanol, or 2-propanol. By using our NMR spectra and seeing that we had a 6 to 1 to 1 ratio with 3 peaks, we were able to finally determine that it was 2-propanol. In 59.1, we again use the same way of determining this to look at our IR and NMR spectra, which then the IR narrowed it down to acetone, ethyl formate, ethyl acetate, and methyl acetate. By looking at our NMR spectra, we noted that it had 3 peaks as well as a 2 to 3 to 3 ratio and allowed us to see that it was ethyl acetate. Looking at 59.2, we can see that we have a C to H benzene ring and a C to H singly bonded carbon. By looking at this, we note that we have 2 peaks and a 2 to 3 ratio. This allowed us to narrow it down to mesidylene and paraxylene. The only one of these that had these NMR were the paraxylene. By looking at this, we can then determine the environmental and health effects of each one of these. Based on the environmental health criteria noted in one of the websites, we were able to see that 2-propanol in high concentrations is actually very harmful to systems and humans and can actually cause drunken-like effects such as nausea, dizziness, and even unconsciousness. Looking at the effects of our second one, we were able to see that it can impair metabolism, weight, and appetite within animals, as well as in humans. It can even cause central nervous system slowing down, or it can cause us to have more problems such as kidney or liver failures. In our third one, we can see that paraxylene in high concentrations can also allow us to have many health effects. In high doses, it can cause things such as tremors and even confusion or respiratory failure. That was noted in one case. All of these, as we can see, in high concentrations, they're very harmful to systems and even in the environment, but in low doses, they don't seem to be very effective or harmful to the environment or to humans. Does anybody have any questions?